Okay, so here we've got a question where we've been presented with a formula and we need to effectively balance it. So we've been asked to balance the equation and specifically asked that only whole numbers should be used in the final balanced formula, right? And so what do we have? So we have effectively barium nitride, right? Ba₃N₂, and that reacts with H₂O to form barium hydroxide and ammonia, effectively, right? NH3. We need to balance this, right? Okay, well, one of the first things I'm going to do in terms of approaching the balancing process is I'm going to look towards effectively auditing both sides of the equation, so the left hand side and the right hand side, to try and really quantify the occurrence of each of the different elements on both sides of the equation, whether it's in the case of like ions, atoms, whatever, but the occurrence of each element. And I'll use the abbreviation LHS for the left hand side, RHS for the right hand side. So LHS. So we've got barium, we've got nitrogen, we've got hydrogen, oxygen, right? So barium, nitrogen, hydrogen, oxygen. And similarly on the right hand side, we would also do some auditing, right? So right hand side, right? So what I'm going to do at this stage is so for the barium, this occurs on in terms of the left hand side. You can see we've got Ba₃, right? So that occurs 3 times. Nitrogen, N2, so you can say that occurs twice. And then for hydrogen, H2, so 2 H₂O, right? So oxygen occurs once. And for the right hand side, oh, I said once, but I wrote a 0, so let me just fix that. Okay, so for the right hand side, we've got so the barium occurs basically once, right? Nitrogen, as you can see, occurs once. So for hydrogen, it occurs in 2 places, right? So it occurs in the OH2 and it occurs in the NH3. So H, which would be effectively 1 here, times the 2, give us 2. And then H3, of course, gives us 3. So we're going to do 2 plus 3, which of course will give us 5, right? And for the oxygen, it just occurs in the barium hydroxide. So that's O times 2. So that's going to be, it occurs twice, right? Okay, so what can we see from here? Well, in effect, none of the elements are balanced, right? None of them are balanced. So it's more a case of strategically looking at, well, what do I want to have a go at balancing first, all right? What I'm going to choose to have a go at first is the barium, right? So I'll have a go at balancing the barium first, and then go towards some of the others later. So if I go towards the balancing the barium, what I can do, given that we've got 3 times more barium in terms of our count on the left hand side compared to the right hand side, we can put a 3 in front of the BaOH2 and see how that affects the count of the rest of the things, since it would affect the count of the oxygen and hydrogen as well. But this would give us a barium count that's 3, right? So let's write out what our equation would be once we've done that. So effectively we get Ba₃N₂ plus H₂O gives us 3, so we're going to put 3 here, BaOH OH2 plus NH3, right? Okay, now let's do an audit. So we didn't change anything on the left hand side just now. So when we do our audit for the left hand side, it's literally going to be the same as this, right? So for the left hand side, we for Ba₃N₂H₂O. So that's just going to be the same, right? So it's just going to be 3, 2, 2, 1. And on the right hand side, this is where we actually did change something. So we do want to pay very close attention. I'm gonna writing this part out. Okay, so as we know, our main aim was actually initially balancing the barium side of things, which is what we did. So here barium is now 3, right? So we've got 3 instead of 1. But then that of course, it was not going to affect the nitrogen count, because nitrogen is over here only. It's only in the species of it's only in the ammonia species, so that's still going to be 1, right? So it's just going to be 1 like it was previously. But hydrogen is going to be affected. So we've got 3 times the 2 times hydrogen, so that's going to be 6. And that 6 is going to be added to this, right? So the 3 from the NH3, so that's going to be 9 for the hydrogen count. So just make sure that's a 9, not an A, right? And for oxygen, it only occurs in this species, and we're multiplying it by 3, right? So it's going to give us 6. Okay. So if we take a look now at what we have as a result of what we just did, you can see that the barium is now balanced, but all of the other elements are still, we've not really got balance. So we do have to consider what might be our next move to get us closer to having a balanced equation. So I would invite you to have a think, well, if we want to get this closer to a balanced equation, what might be a suitable next move? Okay, so when I look at this, one of the things I look at in terms of considering comparison, what we can see here with the nitrogen is that we've got double the amount of nitrogen on the left hand side compared to the right hand side. And nitrogen is one of the species that occurs only in one species on the left, and specifically more relevantly on the right hand side, which has less nitrogen currently, only occurs in one species, which is on the right hand side, it's the ammonia, right? So what I'm going to do is I'm actually going to try and balance this by effectively putting a 2 in front of the NH3, which would double the occurrence of the nitrogen. And so let's see, when I do that, let's see what we get. And let's do again, let's audit that afterwards. So we get Ba, so we get Ba₃N₂ plus H₂O produces 3 Ba₃OH2 plus 2 NH3, right? Now, one of the things which, as we mentioned previously, we again in this iteration we've not done anything to the left hand side, okay, and because we haven't, it will be the same as it was before, so that effectively remains as it was here. So LHS is literally just going to be for Ba₃N₂H₂O. We get the same values that we previously had, so 3, 2, 2, 1. Okay. Now on the right hand side, this is where we did make an adjustment. Now we didn't adjust anything concerning the barium hydroxide. We had a 3 before, we've got 3 now. So as far as the actual count for barium, as is reflected in the equation itself, that remains the same, right? But I'll get to that. Actually, I'll get to the oxygen. Let me just draw this out first. So in the case of the oxygen as well, oxygen occurs only in the barium hydroxide. It doesn't occur, of course, in the ammonia. So because of that, it also doesn't change. It's going to be 6, right? Now, in terms of the nitrogen and the hydrogen, we would observe the, it was our goal anyway to double the nitrogen, so we're going to have 2, which is what we've done. For the hydrogen, on the other hand, so we've got 3 Ba₃OH₂, so it's going to be 3 times effectively H2, so that's going to be 6, right? For the hydrogen so far, it's going to be 6 plus 2 times 3, which is going to be another 6, right? So for the hydrogens, we're actually going to get 12, right? So now if we look at both sides in this case, we can see that the bariums are basically balanced, the nitrogens are basically balanced, but when it comes to the hydrogens and also the oxygen, there's still some progress we need to make, right? Now let's give some consideration to what's really the difference here. Now if you do some visual inspection, you can see that we've actually we need to increase the number of hydrogens on the left hand side by a factor of 6 to get it to be balanced with the right hand side, right? So obviously 12 divided by 2 is equal to 6, right? And when we compare the oxygens as well, what we'll notice is 6 divided by 1 obviously is going to give us 6. So in both cases, the thing that we need to do is increase the hydrogen and also increase the oxygen by a factor of 6. And what you observe on the left hand side quite conveniently is that we've got a H2O, and conveniently in the sense that effectively isolates. We've got hydrogen and oxygen in a single molecule without it affecting. If we put a coefficient in front of the H2O, it's not directly going to affect the number of bariums or nitrogens on the left hand side of the equation. Okay, so that is what I'm going to do. That's going to be my next move. I'm going to put a 6 in front of the H2O, right? So, and that's this H2O right here. So let's do that. So Ba₃N₂ plus 6 H2O, and then that goes to 3 Ba₃OH₂ plus 2 NH3, right? Now, as you would have seen just now, we've not done anything to the right hand side just now, right? So for the right hand side, it is going to be the same as what we just had for our right hand side. So we're going to have simply 3, 2, 12, 6. But we did change something here, right? We put this 6 in front of the H2O, so let's work our way through what we get because of that shift, right? So in the case of barium, we can see we're going to have a 3. We didn't put anything in front of that, so that's fine. Nitrogen, well, it's not going to change. We didn't actually change anything with regards to the nitrogen just now, so that's just simply still going to be 2. Now, but in the case of the hydrogen and the oxygen, we put 6 in front of it, so it's going to be 6 times 2, which is going to be 12, right? And 6 times 1, which is going to be, of course, it's going to be 6. If we now consider again what our, the result of our auditing just now, if we now compare the two, you can see that we've got 3, 3, 2, 2, 12, 12, 6, 6. Effectively, all of the elements are balanced both on the left-hand side when we compare it to, the right-hand side, right? So it's balanced. And because of that, we can say that this, what we've got here is in effect our balanced equation. And as the question specified, we specified whole numbers in the final formula to make it balanced, which is exactly what we've done, right? We've got whole numbers. So what we can do is we can say, well, in this case, it's asked us to balance this 6, 3, 2, right? So we can say that this would be effectively our balanced formula using whole numbers. Okay.